Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
This episode was sponsored by the PVS Studio team. It promotes static code analysis methodology in general and its PVS Studio tools in particular. Static code analyzers allow you to find bugs in source code at the development stage. This helps to reduce the price of fixing them.
PVS Studio performs code analysis and issues warnings on the fragments of code with a high probability of having bugs and potential vulnerabilities in them. The tool supports C, C++, C#, and Java, and it can work with Visual C++, GCC, Clang compilers, and some of those used for embedded systems. The analyzer works on Windows, Linux, and Mac OS. PVS Studio can both be used as a standalone tool and integrated with Visual Studio, IntelliJ IDEA, SonarQube, and so forth.
In the show notes, you can find links to the PVS Studio website and the article Technologies Used in the PVS Studio Code Analyzer for Finding Bugs and Potential Vulnerabilities.
QA tester walks into a bar and orders a beer, then orders 200 beers, then 99 million beers, then negative 3.14159265359 beers, then AXPFD beers. Actual customer walks into the bar and asks where the bathroom is located. The bar explodes in fiery doom for all. That seems a bit extreme, but we've all seen it happen in our applications.
Now, I did not write Microsoft Word.
Defensive programming is about creating long-lasting applications that will graciously handle unexpected inputs from users. It's building code to survive the test of time. In this episode, we're going to look at what is defensive coding, provide some insights into how you can code defensively, and talk about the mindset you'll need to maintain defensive coding practices. But before we get started, Will, what have you been fighting this week?
You mean, what have I been fighting since yesterday when we recorded 2 episodes?
Well, there is that.
I found out I get to wear jeans to the new job if I go on site.
That's nice.
So yeah, it is nice because my wife's running in the Indianapolis Marathon that week. And so I have to go up and then I have to drive down from basically Fort Wayne to Indianapolis, which is nice. I'll still get to be there for the marathon. And I really like this one because they have the chili dogs at the end for free and none of the runners want them, which is why I'm also very happy that I don't have to wear khakis because I'm convinced that probably my love of free chili dogs and other food items has made the khakis not so workable. I'm not sure about that. I haven't tested yet, but that's my good news. Nothing really happened. I don't really have anything to add. How about you?
So, I have the opposite problem. My khakis don't fit me as well because I've lost a lot of weight. But speaking of dressing up, I got to DJ and run the sound for a friend's wedding last week. I didn't talk about it yesterday because I was saving it for today. Took a couple of days off work to help set up for the wedding. It was on Friday, so I took Thursday off and went to the venue, helped them set up, and I did all the sound and sound check and stuff. And then Friday, I had a quiz in the morning and then drove up, did another sound check at the ceremony site and set that stuff up. It was interesting. Even though it rained, they still had the ceremony outside in the rain. Setting up the sound equipment was also very interesting. At least there was a well right near where they were getting married that was inside a barn. Like they built a building around the well. And so on the porch of that, it was a covered porch. We were able to set up the sound equipment, the soundboard, and the speakers and stuff. That's also where the musicians sat. So they're actually hopefully able to get some good pictures of the musicians sitting up there and not get me in those photos because, it doesn't look as rustic and cool when, you've got MacBook and a soundboard there.
It's like a rave in the woods. They just got bug zappers popping on and off.
Not that I have
like a hillbilly rave.
Never been to those. I don't know what you're talking about, Will. Never been to one of those. Never been to a barn party.
I think we need to have one of those.
Oh, yes, that would be awesome. Developer rave. Hey, actually, I bet if we asked Danny, she would help us organize it.
Yeah.
So I actually went to a bonfire and sort of grill out over at her place a couple weeks back. That was pretty cool. Lee Brandt, that does the developer music group here in town,
Yeah.
he was there playing and singing, and it was just a fun night. They asked me to play, but I'm like, the only thing I know are worship songs, and I don't know them well enough to play and sing at the same time.
Yeah.
I'm like, I'm learning, but I'm not there yet, y'all.
Yeah.
So it was a good time at the wedding. The reception was in a barn, and I'd set that up the day before. So all I had to do was just move the speaker and stuff into it. But it was a lot of fun. We had a blast, and, mission accomplished. They are married and on their honeymoon now. So,
Nice.
it's our final week for this book in book club. The final section of How to Think Like a Coder Without Even Trying looks at taking your learning further. It starts with where to go when finished with the book, and this includes a list of things you can do to improve your learning. Next, it talks about coding as a form of volunteering to help your community. And then it has a few games to keep you thinking like a coder and even some deeper concepts to learn more about. We'll have a link to this book in the show notes. And like I said, just about every week, this is a great present for someone who's interested in learning, especially young adult, teenager, maybe even older child. It's written in such a fashion that it would be interesting to multiple levels or age groups. So who's talking to us this week?
We got a Stitcher review from SWD7 saying, really great podcast. One of my top 3 dev podcasts for sure. Funny, helpful, and who doesn't love beards?
Well, apparently Will now because he shaved his, but so this was an old review. I just found out how to get Stitcher reviews a few weeks ago. And so I wanted to give water bottles and the chance for them to the listeners that have given us some reviews historically on Stitcher. So send us a email to waterbottle@completedeveloperpodcast.com because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to LinkedIn, Facebook, and Twitter. We're also on Tumblr and Instagram. You can join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Most of us have heard about the software bug in the Therac 25 radiation therapy machine that caused the death of 5 people. A bug in the onboard guidance system of the ESA's Araine 5 rocket caused it to self-destruct 40 seconds after takeoff. Flaws added to gas pipeline control software by the CIA to trick Soviet spies led to the largest non-nuclear explosion in history.
Defensive programming is a form of defensive design intended to ensure the continuing function of a piece of software under unforeseen circumstances. Defensive programming practices are often used where high availability, safety, or security is needed. If that sounds familiar, it's because it's from Wikipedia, and almost every blog on the topic that I looked at had that quoted at the beginning of it. So when I saw that 5 or 6 times in a row, I decided we just have to put that quote into the episode.
Yeah, and then cite all the places.
Yeah.
So it looks like you got more citations. Like it's a term paper in school, folks. That's really defensive writing, is actually what that is.
Yep. We'll start by defining defensive coding and looking at the differences between offensive and defensive coding. Then we'll discuss several techniques you can use for defensive coding. Next, we'll talk about some do's and don'ts, as well as a few tips. And we'll close out discussing how to create a mindset for defensive design and coding.
So I guess start from the beginning. Defensive coding is a way of designing code to guarantee its continued functioning no matter the circumstance.
Yeah, code should work no matter the inputs. The happy path is the expected correct inputs from the user. Unhappy paths are expected incorrect inputs from the user.
Right. And the crappy path is the path to the end of the sprint as specified by the project manager who doesn't know how difficult things are. That's not in the outline. I added that, just dropping some salt.
Defensive coding. Well, you are definitely salt of the earth type person.
Definitely salty.
Yeah.
At least.
Salty, not sure salt of the earth, but yeah.
Yeah.
Defensive coding handles even the unexpected inputs from the user.
Yeah, these techniques are used when you must have high availability, safety, or strong security, or some combination of those. The app needs to be running constantly or near constantly with little to no downtime for updates or failures. And the problem here is that poor error handling or failure can create security risks.
Yeah, not handling unexpected events creates its own attack surface.
Yeah, this is one that's interesting is how frequently companies will have an error condition that is expensive.
Mm-hmm.
So like if you push weird data at it, it takes more CPU cycles to handle the error. And so if you push a lot of errors, all of a sudden you can take the system down with less traffic than you would just normal attacks. And so you can have an attack magnification surface, or you can have it where it does something weird after an error and it opens up a vulnerability or makes it where something else doesn't work.
You know, one thing I've seen that I didn't include in here is where the logging has taken down a system.
Oh, yeah. I especially love the design where somebody gets something like nlog and they go, yeah, I might need to switch out this logging framework. So let me wrap it and make it extra dumb. And they can't control the amount of stuff going into the log, and they don't really do threading right either. And they've turned it into a text writer and they fill up the hard drive and crash the server.
Yeah.
I've seen that so many times. It's not even funny.
Yep. I've also seen where the logger is set to throw errors.
Yeah. And then to catch them and then write it. Yeah. Yeah. It's the circle of strife and it wounds us all. Sorry. Like I said, dropping salt. It's a Monday night. It's not going to be good.
Mm-hmm. Defensive programming focuses on 3 areas: overall quality, predictability, and comprehensibility.
Yeah. So if you improve the overall quality of the code by reducing the bugs and problems in it, that is probably going to make your system more stable and make it where you can actually survive an attack or survive some kind of system problem.
Mm-hmm.
And the application should function regardless of user input. Obviously that can be kind of interesting at times. It's not just hackers, right? People will do stuff that you just don't expect and that you're like, why would you do that? Stuff like, here's a piece of text. Let me copy the control code for the beep on the console and put it in there. Or they happen to have that in their clipboard for some reason and they pasted it and didn't realize it. And then they typed the rest of their password, for instance, and something weird happens.
Yeah. I always think of, there was this game that we played, I guess it was 8th grade. It's a computer game. But basically you were this little dot or maybe this little stick person, a few pixels here. And you were shooting a laser onto this board and it had these like slashes that were mirrors. When the beam hit that, it turned it at a 45-degree angle. Always.
Yeah, I do vaguely remember that.
And so like, I don't remember if it was you had a set place that you shot from and you had to adjust where you're trying to receive it, or if you the other way, or maybe a little bit of both. I mean, it's been a very, very long time since I've played this game. But what I remember is I was really good at it because, it's pretty straightforward. Some of the guys I was in school with, they would be like, oh, well, it's going to hit here and it's going to bounce back at this 30-degree angle here and then hit here and go at this 125-degree angle over here and bounce.
So what you're saying is basically watching them play it was like watching me play pool.
Yeah.
Okay. Just wanted to clarify that.
Yeah. I mean,
get that out there.
You would look at it and you're like, no, it only goes at a 45-degree angle. If it's coming in horizontal, it's going to hit that and it's going to go vertical. It's not going to go at an angle. It's going to go left and right or up and down. Like those are the only 2 directions it's going to go. But that was my first introduction to people being familiar with something and still not getting it.
Yeah, it's really interesting how often people will form a mental model of how a system works that is 98% right. But when it's wrong, it's hilariously wrong.
Yes.
I mean, you got to think like, we had people that had the mental model that the earth was flat. And I know we're probably going to get some hate from that one flat earth guy, probably even now. But, people had that mental model because if you were a blacksmith in a medieval village, that kind of worked for you. Like you didn't care.
Yeah.
It just happened to be wrong and wildly wrong.
Mhm.
And people do the same thing with software. Like this is not something we've evolved past
No.
by any stretch of the imagination.
Also, under this is comprehensibility, and your source code must be understandable by other developers who will be maintaining it long after you've moved on.
Yeah. And man, the number of companies I've worked for that don't get that
Yeah.
just blows my mind. It's like, yeah, let's just sling garbage at the wall and you don't understand why it takes 4 hours to change the text on a button.
Yeah.
It's because I can't find the button.
No.
Defensive coding is about asking the right questions about the app you're building and then getting the right answers.
Yeah.
It's only using the necessary code and nothing more, and designing the architecture for the big picture of what the app is actually going to be doing.
And this is going to come back several times throughout the episode. This means looking beyond the individual features that you're building and looking at how that feature will interact with the rest of the code base.
Right. And there's so many places that you'll see this kind of stuff come up where they don't really think through the interactions of different parts of the system, especially like in a distributed environment where they'll DDoS their own servers.
Yeah.
I mean, that happens all the time in distributed programming anyway, because it's hard, but it was very, very foreseeable any number of times that I've seen it. You really have to think about how things interact with the rest of the code base. And you also have to think about how the code is going to be extended in the future and how that's going to interact with the rest of the code base.
You need to be able to allow future developers to make additions without a lot of overhead. This will also allow for quicker bug fixes and changes when initially developing the app. Because, planning it out this way is going to not only make it easier for future developers, but easier for yourself as bugs come up.
Right. So that you can fix the system and keep it stable.
We're going to talk about some ways to do that in this episode.
Yeah, so let's talk about offensive code versus defensive code. And offensive code, by the way, is not code that I write. That's just...
It's code that comes out of his mouth.
Yeah, I'm an offensive coder. I don't write offensive code. Offensive coding is a subset of defensive coding that focuses on failing fast, which I do kind of follow that worldview, except I try to recover from it. The idea is not to handle unexpected events, but to quickly identify them.
Yeah, this is really good if your code can't handle the exception. It really shouldn't. Like if you don't have the ability within your code base to handle unexpected exceptions, don't handle them. The code should throw an error or pass the exception up to a higher level that can handle it.
Yeah, which generally speaking means not just catching all exceptions. You need to catch a specific type, at least until you get to the outermost error handler. Just deal with what you can actually deal with. Logging at the top layer and having all the errors bubble up to it might not always work with third-party packages and DLLs. I know I've worked with a lot of systems that have done shell execute, and they write their errors out to a log somewhere, and you don't really get an exception from that stuff. It failed, and you don't really know.
Yeah, I've had several times where you hit something weird with like an ORM, and 90% of the time they're good about throwing an error. No, they're going to wrap the error, and you have to
15 times in the case of Entity Framework.
And you have to dig down to finally get to the actual database error that says that, oh, hey, some moron deleted this column.
Yeah.
That's literally what the error says.
Yeah. That's good. I mean, it needs to be accusative at that point.
Seriously, y'all. A lot of times you'll have this, and I've seen it where it'll eat an error. I've seen this too with code written by some people where they will do a try catch and there's nothing in the catch.
Yeah. It's just like, hey, if an error happens here, then ignore it.
Yeah.
And go on. And there are times that that's okay.
Yeah. You should still log it so that you can track when that's happening. But there are times where it's like, all right, an error happened here. We got to fail over at a higher level when it doesn't return the thing it's supposed to return.
Right. Or where it's like, if this file exists, write to it, otherwise fail. And people don't know that file.exists exists.
Yeah.
And so they'll try to write to it and it's not there and it blows up and they just catch the error and move on. Like it's not good, but it's not going to break the app.
Yeah. You want to use offensive coding when code cannot handle the exception that's thrown. That could be that you just don't know how to handle the error.
Yeah. A classic example of this is a situation where a disk drive is no longer there.
Yeah.
Or it's just dead. Like, what are you going to do? Well, you can't go through the system and try to find a different drive and write to it. that's not going to work.
Mm-hmm.
So you're probably just dead in the water, and you've got to bubble that exception up to something that understands the system enough to straighten it out.
Or if you have an error in your logging framework,
or it's config.
Yeah, or it's config. Yeah, that's one of the things I like about nlog is you can go into the config and turn on the throw error.
Right.
So that if you're like, all right, why is this not logging? And I have done that where I created a test case that literally just threw an error to logged an error. That's all it did was just call the logger and it wasn't showing up. And then I went in and I'm like, oh, the logger is throwing an error because the database connection is wrong, or something like that. That's what it was in that case. But
yeah, or you've got like weird hard coded SQL in the config and it's changed and nobody checked there.
Yeah, that's always frustrating.
Yeah.
Can't say that's ever happened.
Neither of us can say that's ever happened. Non-disclosure agreements.
Ideally, you don't want the code to swallow the exception, but that's not always the case.
Right. Sometimes the only thing that you get that's useful is a stack trace, and you may not really be able to do anything with it. And you just need to dump it to a log, and maybe the app can recover. Maybe you're counting on something higher up doing a retry if it gets a false return value or something like that. Basically, the idea here is that custom exceptions don't exist, and you don't want to create a scenario where something unexpected bubbles up.
Yeah. A lot of times it comes about due to time constraints or overly pressured deadlines.
Yeah.
So you just don't have time to build the error handling in because you're under pressure. However, you need to identify or at least acknowledge when an unexpected event occurs.
Yeah, I've worked on plenty of programs that were just like run once a year, and they had no error handling because it was some goofy script. And, if something screwed up, you just surfaced the error, and the dude that was hitting the button to run the script, fixed whatever the issue was and went back and ran it again. But if the system has to stay up all the time, you can't have that going on. And the deadline thing, holy cow.
Yeah.
Just as far as sources of problems, like, I will also say, too, that a lot of this stuff will come from the overuse of the KISS principle. You can be really focused on each line of code doing exactly what it's supposed to do that you don't think about what happens if it doesn't.
It also happens when you're so focused on the effects of a particular segment of code that you don't think about any potential side effects what you're doing is going to have.
Right. Like if you're allocating memory to a level that maybe is going to throw an out of memory exception, which, by the way, won't get caught by the .NET try catches.
Yeah.
Because it can't, because it's got to allocate memory to catch. It's like, that's not going to work.
Yeah. No. This is worse with legacy systems where no one is still around from when it was originally written.
Yeah. And the guy that replaced that guy isn't around either.
Yeah.
Because a lot of these systems, I mean, it's like cargo cult programming. They're like, this worked last time, I'll just do this here. And they don't critically examine it because it's a critical system, and surprise.
Yeah. So defensive coding is about developing the feature that the user needs in a manner that is maintainable and doesn't interfere with the existing functionality. Here, the idea is to be prepared for unexpected events.
Yeah, and that means handling them gracefully. And that's more than logging an error, right? Like you need to go on and be able to return and have the app be in a state that it's not broken, whatever that looks like.
It could be recursion. It could be retrying a particular function call or having a special path for unexpected events or inputs.
Yeah, the idea with defensive coding is to design a sustainable architecture from the start so that when this stuff happens, you have some way to figure out what it is and quickly fix it, and so that it doesn't take the whole system down. Both of those things really have to be there. And this needs to occur before any code is ever written. Like you don't get a year into this and decide, I want to make this, defensively coded, because that's going to be rough trying to fix it all.
A lot of times this is a mental game that you do sort of while relaxing before starting a project or app, where you think about, all right, what all possible things could go wrong? You build that in and then you go, well, what am I not thinking about? How am I going to handle something that's completely off the wall?
Right.
What's the weirdest thing that Beej or Will would do to try to break my system?
Or the crazy QA guy. Or it could be a crazy QA guy, it could be a crazy QA gal. But either way, everybody's got one in mind that they think of.
Yeah.
Like the guy that used to like run your code and have it hit a floppy disk and be able to time it so he could pull the disc out while it was writing, or just weird stuff like that. Think about what somebody who is trying to get you fired for the quality of your code would do to you. And that's your thought process there.
Because you're not going to know what they're going to do. You just need to be able to handle anything they're going to throw at you.
Right.
It also involves asking the right questions and understanding the subject material enough to ask intelligent questions about what you're building.
Right. And I mean, the real thing with defensive coding is that you've got to get the big picture in mind to the degree that you can figure out all the little weird nooks and crannies that are going on. And you have to also leave doors open for unplanned or even impossible features at that time. It's amazing how many apps out there didn't consider what would happen when the internet got fast enough to be broadband. Like there's stuff that failed all the time because they had timing issues in there. They didn't realize that, hey, one day people are going to have something faster than a residential telephone modem.
Yeah. So I believe it was XKCD that did this. I mean, most of my comics come from them, but it was a guy goes in to have a procedure done at the doctor's office, and he walks in with the USB port, and he's like, holds out his arm. He's like, "Could you install this while you're in there?" They're like, what? He's like, "I know it won't work now, but eventually there'll be a patch or an update that allows it to work." And underneath of it, it goes Linux user.
Yeah. That's about right. I don't think I would want to install System D. I think that's on myself. That would seem like that would probably go poorly. You really have to think about all the constraints that you are dealing with all the time.
Mm-hmm.
And that's everything from hardware to the intelligence level of the people that are operating the machines. Either really, really dumb or really, really smart people. If you're not expecting them, those people will ruin your day.
Mm-hmm. This also includes an idea of where things could go wrong within your application. You need to know the details about what functionality is needed from the application. Like, how is it being used? What are they getting out of it? Also, with this, exception handling is a key component of defensive coding.
Yeah, it's probably the first one that everybody thinks of, but it's hard. It's more than just logging and swallowing an error. We've all done this for one reason or another, and it usually comes back to bite us. Sometimes we get a different job before it does, and that's great too. That's defensive coding as well, my opinion.
I don't know if that's defensive coding or defensive job hopping.
It's defensive, whatever it is. Yeah. In addition to logging, descriptive errors have to be sent to the user so that the user can know what's actually going wrong. Like you just can't give them a memory address and a dump.
Yeah.
Like they have to be able to, the user needs to be able to recover. Yeah. So your app could be a situation where it's got failures, but if the user can see how they're screwing up, they can still get through and you can meet a service level agreement and it's still okay.
Oh. So now that we've talked about what defensive coding is and kind of compared it to offensive coding, we're going to talk about some techniques for defensive coding. First off, reuse existing source code as often as possible.
Because it's been tested.
Yes. And it has known functionality and known quirks.
And that means known to your team as well, right? Like the whole not invented here thing. One of the big problems with that isn't just that you may get bugs that you don't expect, but that your team may form a mental model of the code that isn't correct.
Mm-hmm. You want to look at the when and the why code was written. Well-tested legacy code may have been written before some problems were even known or existed. Back in the 90s and early 2000s, the internet was a much more trusted place than it is now.
Yeah. Well, it's interesting, like the definition of trusted gets a little squirrely there too, because it was also not as critical to have to trust
That's true. That's true.
It was like the guy in the shack down the road as far as trust level versus the roommate, because it just wasn't as involved in the deeper aspects of your life. And yeah, I mean, if you look at SMTP, you can tell they built that for a different world. Mm-hmm. That is just not the way anybody does things, and they didn't think that people would abuse the system.
Yeah. There's quite a few things I'm sure that I did that would get me in a lot of trouble now. But back then, it was just, you were trying to learn stuff and learn how to do things.
And poking at systems and testing stuff out. And the thing is like, I think everybody that's a programmer of a certain generation probably has some stories that they can't tell. from that time period. And it was like everything was more trusting and it was not as secure and people weren't as paranoid.
I mean, realistically, it was the code written back then that led to things like the OWASP top 10.
Yeah, if you're getting a security audit, you are paying for the sins of my generation. You also have to watch out for legacy problems. There are problems in older designs that may not work with new requirements. One really bad one, a lot of times, is the way that they handle threading.
Mhm.
They thought that Moore's Law was going to keep going and they could just throw more hardware at stuff. And yeah, you can, but it's not the same way. And stuff wasn't broken up. And so you may get performance problems that lead to security issues or lead to failures.
I mean, the older designs weren't tested with new hardware, new requirements in mind. And legacy code most likely was not written defensively.
Yeah, it was so common back in the day that your systems were not on the open internet.
Yeah.
It was a system inside an office somewhere and maybe nobody had an internet connection, or it was like an old like the old teletype type stuff. I mean, they didn't have people in the office downloading stuff that didn't need to be getting downloaded and running it on the machines.
Yeah.
The world changed. I remember like in the late 90s and early 2000s when some of the viruses and stuff started hitting, like the I love you virus. Like people were just, they get an email that says I love you and they would open it and they trusted the people that sent the emails. They didn't realize that a virus could do that.
Mm-hmm. And the other thing is it could have been written and tested under circumstances that no longer apply, business circumstances that no longer apply. I've had this happen to me in the middle of development on an app where legislation changed the way that the business had to do things.
Yeah. And, the other thing is like the legislation could even make part of your app illegal,
Yeah.
and that's a failure case too, especially when it's deep down in the design and you can't fix it. One other thing that may have happened as well is canonicalization can be a real problem. So back in the day, what we used to do is we used to filter stuff and manually handle things that a lot of string libraries handle now. Like, oh, I'm going to take all the backslashes in this and turn them into forward slashes because my operating system doesn't handle that well.
Mm-hmm.
You really can't do that anymore. You need to use a library that was made by somebody who really knows that stuff, because that's one way for problems to sneak in.
So canonicalization is the process of converting user input into a standard data format. It's also known as normalization or standardization.
Or decrapification is the other phrase I hear frequently.
It's basically used to count or compare data structures. It can also help improve algorithm efficiency.
And this is especially important for file names and paths in security. So like your app may have access to a particular folder or file, but using features built to help traverse the file storage by way of the command line, for instance, // can allow malicious input access to other areas.
Mm-hmm.
So like, for instance, in a web browser, you could have a URL and you could, do a // from there and get above the level of the domain that you're actually on and hit something else under Apache.
Mm-hmm.
Now, that's not been an issue for ages and ages, but I do remember at some point early on, that was a thing.
Yeah. That's just a good example of using canonicalization or normalization will help you reduce the attack surface for those kinds of attacks or other things as well.
Yeah.
String comparison can become tricky when adding accents to letters.
Yeah, so it's interesting because we have a bias towards the way that strings work here in the West, and they don't work that way even across the West.
Yeah.
All you got to do is get to Quebec. Besides all the letters that they don't pronounce when they're in the word, they also, do string comparison differently and you can get burned.
Mm-hmm.
And it gets worse the further away from English that you get as far as how things work. There's like casing and all that kind of stuff, and stuff doesn't get sorted the way you would think or doesn't get compared the way you would think, or sometimes the accents are optional and sometimes they're not.
Mm-hmm.
Language is a weird thing.
It's interesting too the way it's encoded, because it's possible to have two Unicode characters, one for the letter and one for the accent.
Right.
But then there's also a Unicode character representing the letter with the accent.
Yes.
So what this whole process of standardization does is it takes those and it puts them all into the same format, either the two characters or the one character, and that allows for easier comparisons. They don't have to take into account all possible ways of creating the same character.
Right. Yeah, the standardization is very important. Another one that comes up a lot is canonical XML specifications. So you have to standardize XML documents in a way that allows you to traverse them cleanly in the same way every time. So it's like a pre-processing step almost.
Mm-hmm.
This is getting rid of things like redundant namespaces, extra white spaces in the tags so that, somebody can't put in 2 spaces and break the app. That's sort of important. It also transforms relative URIs into absolute URIs so that you can actually prove that something is the same versus, well, it's the same, but we moved this document and now it's not the same.
Mm-hmm. Next, you want to have a low tolerance against potential bugs. First off, under this, follow the smelly code to find where it's not very fresh.
Right. And assume that if it looks problematic, that it is probably problematic. Code that looks weird, a lot of times has weird bugs in it. And fix the bugs as soon as they're found. And that means actual fixes, not hacks.
And if you've got an area that is just prone to be buggy, look into refactoring that as soon as possible.
Right. Because here's the thing about areas like this, people react to them.
Mm-hmm.
Okay. People calling that code react to it and they go, hey, this area is buggy and it's a giant pile of crap. Let me try to work around that so that my module doesn't break.
Yeah.
And they're defensive against what's coming out of that thing. And so you end up with like all this cruft around it that can cause more problems because it's doing stuff that's not necessary because this code's busted.
The thing is, they're not properly being defensive against it.
Right.
Which is what we're about to talk about. Because before we get into that, all bugs are potential security holes.
Yeah.
You can't know all types of security exploits, and new ones are coming out all the time. You need to protect your code against even the ones you don't know about. And so these bugs are going to provide an attack surface.
And the big one is check the validity of inputs by using a design by contract or an assertive programming model. And you're going to have to check things, basically at every level because you don't know that you didn't get a new caller.
Mm-hmm. So design by contract, make sure that data is sanitized. It does so by using preconditions, postconditions, and invariants. We've talked about this in previous episodes. The code is able to document assumptions. That means that arguments passed into functions are validated before the function is executed. So you're checking what's being passed in.
In other words, if they're passing in a null, they don't enter the function.
Right.
Potentially.
If you can't pass in a null. Now, if it's allowed, that's different. But yeah.
Right.
Yeah, you're not allowed to pass in the wrong type if you have a strongly typed language. If you have JavaScript, then this is where this kind of becomes important.
Yeah.
You don't want to pass in, AXFD beers.
Yeah, or just object to object.
Yeah.
And I mean, the big thing here is you also have to check within a function, do a state check before the value is returned from the function, just to make sure that you got something that wasn't crazy. Because again, you may be calling other code and it may do something weird.
Mm-hmm.
And so you're going to want to catch that before you bubble it up.
No. When calling a function, you want to assert that you are not referencing something that is invalid.
So you make sure, arrays, great example.
Make sure your links are valid.
Yeah, it's interesting. There's some functions where you pass the array and then you pass the length in.
Mm-hmm.
And if you go look, a lot of those will check to make sure that those match.
Another thing we've mentioned is null checks. If you're passing something in that can't be null. So this is something I've seen a lot of, and I've had to do some where it's, all right, we're using a nullable integer for this, but I have to pass it into a function and I have to do a has value on it and then pass in the value. You can still pass it in like dot value and it'll do that. I think there's a dot defaulter value that'll pass in a 0 and then within that function you check. But yeah.
I believe so, yeah.
Yeah, so that's C sharp, but still it's like that's doing that just at a different level within the call.
Right.
This is especially important if the function takes a non-nullable, but the value you're passing is nullable and the function doesn't have a default value.
Right. So, this gets into a lot of stuff that we have to deal with, both of us, on the regular. You have to kind of have a small validation library for asserting and checking values before passing them because you need to do it the same way every time.
Mm-hmm.
Otherwise, it gets down the stack and it finds the one that wasn't implemented the right way and you have a weird bug.
Yeah. And make sure to include logging so you can trace a path if something isn't validated. This also just helps reduce the tedium of defensive coding. Like, for example, I have a has value extension of the object class that checks custom objects and classes so that I'm not passing in something that is null and throwing an error. I can run that and go, oh, hey, if this is null, then I can initialize it before I pass it in.
Right.
And then I don't have to worry about that in my lower classes, in my logic layer and stuff like that.
Another thing too is don't trust libraries that you didn't write. Also, don't trust libraries that you did write. Check everything. This is not a place to make an assumption because you could also go, oh, okay, I'm the one that wrote this, but we had some junior dev in here a year ago and he happened to mess with it and we didn't catch it till now.
So on that, now we're going to talk about some of the do's and don'ts of defensive coding.
And don't ever trust user input. It's a little bit less reliable than gossip. As far as reliability, always assume that you'll get something unexpected from the user, either accidentally or maliciously.
Yeah.
Or stupidly.
Like, you know all the functionality and how it's supposed to work. Testers know what it's supposed to do and likely know what expected invalid inputs are going to be.
And users don't know any of it.
So they have their own ideas about what your app should do. You know, they're going to walk into a bar and ask for the bathroom.
Yeah. Or they're going to be using a speech to text interface and their kid's going to scream into the microphone right before they hit submit. You know, just like you just never know what a user's going to do. Like it is appalling when you experience that. And assume that everything that's unexpected is potentially malicious. In fact, it's probably just better just to straight up assume that it is malicious until you find out otherwise.
In reality, most of it will just be poor user training or incompetence. However, by assuming it's all malicious, you won't miss something hiding out as an incompetent user.
Right. Well, the incompetent users are often the vectors for the malicious stuff anyway. So, you know.
So the thing is, you're not coding for the 99% of the time that it's safe, but the 1% that it's malicious. And percentages may vary on that.
Yep. And you'll never know what they are. Use whitelists, not blacklists. So filter by what's allowed, not by what is not allowed.
Doing this will ensure that you know what you're working with. For example, when validating upload MIME types, something I've had to do, don't look for the invalid types. Instead, only allow the valid ones.
Right. You know, valid MIME types are always silent. Sorry, it was just sitting there.
I left it
not
open
my fault.
for you.
I've got a condition. Use database abstraction, please. Like, let's not continue concatenating SQL strings and then calling it, including within SQL, please.
So this is number 1 on the OWASP top 10, injection. And it's been number 1 since the beginning of the list. It's such an issue that it's remained at the top of the list of vulnerabilities since the list's inception in 2003. Think about that.
Right. It will always be on the list of vulnerabilities because honestly, SQL, the language does not have a good way of saying, hey, I don't trust this input. Don't do anything stupid.
And it's not just SQL, it's any injection. But injection happens when code is put in instead of the usual input. This can lead to all sorts of problems. And we have overused, and it's been a while since we've mentioned it, so I felt comfortable bringing this up. And it is my favorite XKCD, exploits of a mom, little Bobby tables.
Right. And just putting in certain characters that end a SQL string, you know, in the current one, and then starting a new one, and that gets executed when some goober concatenates it, you're going to have a bad time. You can also do this with LDAP queries and all kinds of other things. Like, it's not just databases. It's just that databases usually are where the expensive data is. And so that's what gets hit.
What you want to do is parameterize your inputs going into the database. Most ORMs will do this for you. That's kind of one of the reasons they were built. What it does is it stringifies any user input that might be malicious code. So it just goes in as a string and not like a closing statement for the SQL.
Right. And don't reinvent the wheel. Use a framework where it's available. They're there to reduce the redundancy that makes you complacent in development. Plus, you're going to get rushed when you're working on any project in development. And so if you built it yourself, it's guaranteed that you're not covering all the error cases that you really should.
Yeah. I mean, these have been built and tested by large teams of people and used by a lot of other, they've been not only tested in the lab, but they've been battle tested. Use them where you don't need to create something new.
And don't create new functions or features when you could use existing ones. The existing code is already tested in the wild. You don't go messing with it and adding another path because that adds complexity. It's not just that you may be wrong, it's also that it makes it harder to test the stupid thing.
The only time really that you need to create something new is if what exists doesn't fit your needs. Just remember when you do this, validate your inputs and outputs when you're using any existing code.
Right.
And finally, do create tests before your code gets to QA.
Writing tests will help you stick to best practices. This could be everything from using solid principles to specific design patterns. Your tests will help you ensure that you are following these practices because for something to be testable, usually you're doing it right.
Use them to test your code and your objects. You'll see just how many objects your small code changes affect when you're mocking them up. You'll realize, oh my goodness, I didn't realize it touched all these places.
Yeah. And especially like when it's second and third order consequences.
And this will give you insight into integration testing and what all could be affected.
Right. So I guess let's talk through some tips for effective defensive coding. First one, write your code as cleanly as possible. This will improve the ability of other people to comprehend that code, so they're less likely to screw up.
Mm-hmm. Make the functionality and responsibility of your code very clear because that lowers the risk of inept users misunderstanding or misusing the code. Notice I didn't say it completely removes the risk.
Right. Like the way you remove the risk is never have anybody code at all.
Yeah.
It's in the game. There's going to be a risk. Also, keep your methods specific and focused and really be careful about side effects.
You want to name them according to what they do and spend some time with naming them and naming the variables to make them legible, unless you're me and tell a story.
Yeah, clean code is easier to maintain. When you can see what the previous developer was attempting to do, it makes fixing issues much easier. Being the only person who can maintain your code means basically never going on a vacation.
Or being interrupted whenever you're on vacation. I was at the dentist not long ago and I got a message from QA and I literally said, I am at the dentist. And it was less a matter of I wasn't the only one that could look at it. It was I was the only one this QA trusted to ask a question to.
Yeah.
Who to ask a question
of that part of the system yeah. I mean, I've worked at places where they didn't prioritize clean code and it's, like where you get the question of why would you change the name of a function?
Mm-hmm.
And it's like, because it doesn't do that.
Yeah.
Like it's literally a lie. Like don't have those kind of things because people make assumptions. It really jumps up and bites you. Also, prefer descriptive exceptions over return codes. I still would say put the return code in there, but make it clear what actually went wrong.
Return readable exceptions that express the part of the app that is not working. This could be enforcing part of an API contract, a lot of other things. You want to guide the user of your app or your API to a solution, not confuse them.
Yeah, my favorite API return is a blank.
Yeah.
By the way, that's like my total favorite because then you can't fix it.
The thing with error codes or return codes is really all they do is slow down the process of finding a solution.
Yeah. The only time they're really helpful is when you can put that code in and then you can do a search on the code itself and find where it's thrown. But beyond that, they're not very helpful for end users. Also, don't send system details in your error response. So, log stack traces and all that stuff, but send a message back that explains what went wrong in English.
Yeah.
So invalid input for whatever will tell the user what they need to know without exposing the system. They don't need to see the stack trace.
Yeah, send something like you can't order ASDF beers because ASDF isn't a number.
Right. Another thing, assume that you're in hostile territory because you are. Even if you think that this thing is only going to run inside your server room, you can't guarantee that somebody hasn't gotten in there. So by definition, you're in a hostile territory. Always assume that. Start with the assumption that your code will constantly be under attack.
You will not know when or where the attack on your code is going to take place. What you do know is that it's going to come.
Right.
Malicious users will attempt to exploit any weakness they can find in your application. And defensive coding is about not only preparing for the known attacks, but having contingencies in place for unknown attacks.
Right. In other words, fail closed.
Yeah.
That's the real thing. It's like, hey, if you get unexpected input, they don't get their output. Sorry.
Mm-hmm. Finally, we're going to talk about developing a defensive mindset.
And the first thing is know the purpose of the code that you're writing. If you don't know that, don't start writing it.
Learn enough about the business to know how your app will be used. Find out not only what the app will be doing, but how they would do it without the app. What's the long form? What's the paper form? Knowing the long
Right.
process is going to help you understand how to make that simpler.
Right. And if you understand also the areas on that paper process that people try to circumvent, you probably know the likely attack surface on the digital version as well.
I had a very frustrated customer. I was working on this one project where they no longer had access, like direct access to their database to manipulate the data. So like, oh, well, I need to be able to change this for reports and then I'll change it back for this. And we didn't realize they were going around the old system so much.
Yeah.
And I was like, well, I'm not ever going to use this. We're just going to keep putting it in the old system because of that. And I'm just going to. And so what we ended up doing was we gave her a spreadsheet. So you just like print out a spreadsheet and then go into Excel and move stuff around because that's all she really wanted.
Right.
But it was this huge ordeal until we got to that point
Yep.
because we did not, I say we, the BA I was working with at the time did not take the time to figure out how are you using this system.
Right. What kind of weird crap are you doing just to get through your day? And people won't tell you that either. If they've been doing something to kind of sneak around the system, they won't tell you whether it's malicious or not.
Your app is there to help the business do its job. This is not the time to show how intelligent you can be.
Yeah.
Remember, debugging is always harder than the original coding.
Yeah. And if you don't know why you're writing it, your code is going to be bad. The code might be flawless and execute exactly as written, but it's not going to meet the business needs because you don't know what they are.
Mm-hmm.
When this happens, the users are going to start looking for ways around your code, and you're basically creating a cycle where they try to exploit the system.
Yeah. And this can lead to them creating their own security issues, such as emailing social security numbers and, HIPAA data or personal identifiable data, stuff like that, that the average user may have gone through training 5 years ago on when they first started the company, but they've forgotten that now. And they just need to send this data over to someone else in the company.
Yeah.
And they'll use unsecure means if your application is too difficult for them.
And speaking of things that are too difficult, write your code with maintenance in mind. I mean, we've all been guilty of writing code to solve the immediate issue, sometimes getting a little too clever. This could be anything from hard-coded values or using improper design patterns. When you got to get stuff done quickly, this really jumps up and bites you.
Mm-hmm. What it does is it encourages future developers who are maintaining it to create vulnerabilities. It's even worse when it becomes legacy code that someone has to come in and learn because
Right.
they may create vulnerabilities not knowing they're doing it where you knew, oh, hey, yeah, I built that with like this potential hole, but I know how to work around it so that I don't cause that. Well, is the developer that comes in 5 years from now going to know that? 10 years from now?
Yeah. And are they already frustrated with the code base?
Yeah.
Because it's bad for their career and they're just trying to get through it. So keep it maintainable because the social dynamics are not to be underestimated.
Next, be consistent throughout your code base.
Yes.
If you do something one way in one place, do it that way in all the places.
Inconsistent code is hard to read and hard to understand, and it will make you make bad assumptions. The other thing is you're not defending against other developers on your team. So if you confuse them, you're going to have problems as the code base ages.
Mm-hmm. When working with multiple developers, create coding standards. This will ensure that the code is consistent no matter who wrote it. If you're having trouble getting buy-in from fellow developers, you can make it a requirement for accepting pull requests. I've seen this at places, especially if they're using Git.
Yeah.
It makes it really easy when you've got like, all right, one of the lead developers has to review it and make sure it meets the coding standards.
Right.
Now, finally, resist the urge to add more features.
Right. So like if you're coding things that you think are going to happen or they're requested in meetings, but they're not approved yet, stop doing that because you will put a hole in something real fast doing that.
Your foresight isn't that great.
Yeah.
No one's is that great. Also, your default should always be no to new code changes unless it's in a planning meeting.
Right. And it's planned.
I used to have a bad habit of this because I would be in there working on something and I would see a way to make their job easier. And it wasn't part of what we were building. And I'd be like, oh, hey, if we built this, it would make doing your job so much easier and you could like do all this other stuff. It got to a point where one of the BAs that I was working with said to me, "Hey, look, I know you're excited. I know you got some really great ideas, but tell me first."
Yeah. Let it go through the proper channels and let it mellow a bit.
Yeah.
Because it is really hard to predict what's going to be necessary. And getting away from your main focus can also introduce security holes. Like you go off on a tangent for half a day and do that. When you come back, you forget some little fact and you introduce a security hole.
Mm-hmm. Resist adding more code or features until you're sure they're necessary. These extra changes take time away from your main focus. And like Will said, they also increase your security. To know if a new feature is needed, look back at the app's purpose. Ask if the new change helps achieve that purpose. If so, then it's a necessary change. Y'all, defensive programming is a way of thinking and writing your code to be on the lookout for the unexpected. Your code will get blindsided at some point in its lifetime. Use the information here to help mitigate that when it happens. Build your software so that it is capable of handling the unexpected challenges it will face when you release it into the wild. That pretty much wraps it up. Will, before we close everything out, what do you have for us this week for Tricks of the Trade?
Well, I know this episode probably came across as mildly paranoid, and that was intended by both of us as we were talking through this stuff. Paranoia is healthy when they are out to get you. And if your system is doing anything interesting, they are. Because you've got sensitive data, you've got the ability to infect users with a botnet, whatever kind of, other bad things that could happen. If you're doing a real software system now, including video games, then you're in the soup as far as this is concerned. You cannot ignore security anymore. I just want to drive that home by thinking about just how bad something could go. Spend some quality time actually thinking about if my app is used in the worst possible way and is breached in this way and this way, how bad is it? Because I guarantee you that if you really look at that, you will become a very paranoid person because it's there. And so I'm just going to tell you, paranoia is really healthy when they are out to get you. And in this situation, when you're running code, especially on the open internet, that's the way it is.
Yeah, you got to watch out because you'll be underground with the moles digging holes.
That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.